Hello everyone, I hope you're doing well today. Today we're going to delve into solving exponential equations. An exponential equation is an equation where the unknown value, or the variable, is in the exponent. Let's take a look at an example. If I look at the equation, 5 to the 2x equals 5 to the 22, I notice my variable x is in the exponent on the left-hand side. What's nice about this particular equation is if I look at my bases on both sides, the base is 5. If the bases are the same on both sides of the equation, then the exponents are equal to each other. So I can solve for x by writing the equation 2x equals 22. To solve for x, I would just have to divide both sides of the equation by 2 and I get x equals 11. Now let's take a look at an example that's a little bit trickier. What makes this one trickier is that my bases are not the same. I have a base of 2 and a base of 32. However, what's nice about this particular equation is that 32 is a power of 2. 2 to the 5th is equal to 32. So I can rewrite my equation by changing 32 to 2 to the 5th. So my equation becomes 2 to the x minus 3 equals 2 to the 5th to the 3x. Now using my power of a power rule, I take my exponent 5 and 3x and multiply them together, and I can write my equation as 2 to the quantity of x minus 3 equals 2 to the 15x. Now that my bases are equal to each other, so are my exponents. So x minus 3 equals 15x. To solve this equation, I would first subtract x from both sides of the equation and get 3 is equal to 14x, and then divide both sides of the equation by 14 to get x equals negative 3/14. Please take a moment to pause this video and record these examples in your notes. Now I'd like to take a look at another example. 25 to the 2x equals 125 to the quantity of x minus 8. Now, 125 is not a power of 25, so I can't rewrite just one side of my equation. I have to try to rewrite both and find out a number that 25 and 125 are both powers of. Well, 5 to the second is 25, and 5 to the third is 125. So I can rewrite my equation as 5 to the second to the 2x equals 5 to the third to the quantity of x minus 8. Now using my power of a power rule, I need to multiply together my 2 and 2x to rewrite the left-hand side as 5 to the 4x equals, multiplying the 3 times the quantity of x minus 8, 5 to the 3x minus 24. Now that my bases are equal, so are my exponents, and I can write the equation 4x equals 3x minus 24. To solve this equation, I would subtract 3x from both sides and get x is equal to negative 24. Please take a moment to pause this video and record this example in your notes. Not all exponential equations can be solved by rewriting it and using the properties of exponents. So we need to use an inverse operation. Just like multiplication is the inverse of division, multiplication undoes division, a logarithm is the inverse of an exponent. So to solve the equation 7 to the x equals 13, I'm going to use logarithms. Logarithms are abbreviated just as log or log. So I'm going to take the log of both sides of my equation here. So I'd get the log of 7 to the x equals the log of 13. Using what's known as the power property of exponents, I take my exponent and bring it down and turn it into multiplication in front of the log. So I can rewrite this as x times the log of 7 equals the log of 13. Now, since x is being multiplied by the log of 7, to isolate it, I would divide both sides of my equation by the log of 7. At this point, this becomes a calculator problem, so you would plug in log of 13 divided by log of 7 on a calculator. And get that x is approximately equal to 1.318. Now let's take a look at another example that also requires the use of logarithms. 3 to the quantity of 2x plus 1 equals 5. Again, I'm going to start off by taking the log of both sides of the equation. Applying the power property of logarithms, I'm going to take the 2x plus 1, bring it down in front, and multiply by the log of 3. Now to isolate my variable, I'm going to start off by dividing both sides of my equation by the log of 3. And I have 2x plus 1 equals the log of 5 divided by the log of 3. To isolate the x, I would next subtract 1 from both sides of the equation and get 2x equals the log of 5 divided by the log of 3 minus 1, and finally I would divide both sides of my equation by 2 to get x by itself. At this point, it becomes another calculator problem. So I would type in the numerator of my expression inside parentheses. So I've got parentheses, open parentheses, log 5, close parentheses, divided by log 3, close parentheses, minus 1, close parentheses, all divided by 2. And I get that x is approximately equal to 2.32. Please take a moment to pause this video and record these examples in your notes. Before we wrap up today, I'd like to look at one more example. 3 times 5 to the quantity of x minus 2 plus 2 equals 29. The first thing I need to do is isolate the exponential expression. So I would subtract 2 from both sides of my equation. So it becomes 3 times 5 to the quantity of x minus 2 equals 27. Then I would divide both sides of the equation by 3, and my equation becomes 5 to the quantity of x minus 2 equals 9. Now, to undo the exponent, I'm going to take the log of both sides of the equation. So I have log of 5 to the quantity of x minus 2 equals log of 9. Applying the power property of logarithms, I take my exponent, bring it down in front, and multiply. So I have x, the quantity of x minus 2 times log of 5 equals log of 9. To isolate the x, I'm going to first divide both sides of the equation by log of 5 and get x minus 2 equals log of 9 divided by log of 5. And then to finish isolating the x, I would add 2 to both sides of the equation and get that x is equal to log of 9 divided by log of 5 plus 2. And now I would use my calculator to evaluate. And I get that x is approximately equal to 3.365. Please take a moment to pause this video, record this example, as well as any questions that you may have in your notes, and I will see you shortly in our Zoom meeting. Take care.